Hi, this video is for Kurtis Baute, YouTuber. I watched your video on how I proved the earth is round with my bike and 2 sticks. And I thought it was a pretty cool video. I like how you rode your bike over 100 kilometers, I think it was, and got a difference in sun angle measurement of 1.5 degrees, and you said that that proves the Earth is a sphere. Now, I studied math and computer science, so that's the background I come from. And when I do a math problem, I don't care about the beliefs. I push that aside so it doesn't matter. In fact, keep it a mystery, whether you think what I believe, whether the Earth is round or flat or anything, heliocentric or something like that. And I'm going to play the devil's advocate, and I will challenge you, and you can either take this as a math approach, because I didn't actually check all the math on it. I'll tell you exactly what I didn't check on it. I didn't carefully check all your assumptions. I know you said something about, I think you were assuming that the sun was very far away. But I'm going to show you a model that somebody made. And I don't think they believe the Earth is flat, but they made the model just to show mathematically what kind of models you can make up with given what we see. So I'm going to show you that model, and let me pause this video and then I'll show you it on my screen. So how do I stop this? Okay, cool. So here we have a model that one guy made. I guess I can put the link in the description, and he goes into a lot of information about it, and he basically talks about problems with the model and things that you can actually have the exact same. So here we go. We have days of the year that we can change. So obviously if you know it's early in the year, or if it's like winter, we have that model. And then if we have, okay, yep, I can see that. So you know how like at the North Pole, it's like basically it's like one day for the whole year. You can see that with this light. Now I'm going to explain. I was kind of confused when I first saw this, because I was just like, well, what about the sun setting going past the horizon? And then I realized, trying to read about it and seeing how that worked, is this model actually assumes that there's something happening with the atmosphere, or something happening with the way light bends, so that this path right here is the light from the sun. And notice how it's bending so much that it actually ends up going pretty much horizontal by the time it hits here. In fact, it's on the horizon here. So if light bended in this way, then when you're at sea level, it would basically look precisely the same. Like, it would look exactly as though you were on an actual planet, or whether you were, if you were in this type of dome thingy. Now, he does point out that this doesn't account for like sizes. So like the size of Australia will be like wrong, because you'll measure it and then you'll be like, yeah, this somehow doesn't add up. But as far as like observing the sun, I guess this gives you the same thing. Now here you can change where you are on the Earth with your latitude and longitude. So I'm going to show you something really quick here. So you rode your bike from Regina, I don't know how you pronounce that, to Stoughton, or maybe the other way around. I think you went from Stoughton to Regina, I don't remember. For some reason, Wikipedia puts the minutes and seconds as far as the longitude and latitude. And Stoughton just gives you a decimal. So what I did was I looked up the conversion here, and then I got the two different things here. And I also put 11 in the morning, or 11 hours, and then I put basically 204 days, because that was about the time of year, I think, that you did that bike ride. So we have around like kind of early July these two different places, and it's a very slight difference because you just rode your bike, you know, like 100 kilometers or something. But notice that even in this model, the azimuth and the elevation of the sun changed. Now this is the part of the math that I actually didn't end up really verifying and seeing how. I didn't look to see how the angles worked, so you can double check how this works. But if you notice, the sun's azimuth goes from 80.5 to 79.6 on this one, and 16.4 to 17.2. So those are slightly different. It's about maybe a degree and a half. And this is basically the type of model that you'd essentially be wanting to essentially quote-unquote prove wrong if you want to quote-unquote, I'd say, prove the Earth is a sphere. Now what you are proving in this case is not necessarily that this model's wrong, and sadly you're not exactly proving that the Earth is actually a sphere, because there's models like this out there, but you are disproving an older model that basically assumes that the Earth is in the center and like the sun goes around it by doing your calculation. So it's good to get the different evidences, the different tests going on. But if you want to take me up on this challenge and say, no, I really want to prove that the Earth is a sphere, I want to, you know, I'm dedicated to science, check the link in the description for this website, and read what he says about the distances. So here we have Australia being really stretched, kind of. So look at this model that he made. This guy must know a thing or two about like trigonometry or something if he made the simulation. And try to figure out how this model works. This flat Earth with a dome, but also with like some kind of light bending. Like it makes an assumption about how atmosphere light bending works with the sun. So you'll notice that this right here represents the horizon, and by this time the light bends here, if you're standing here, you're not actually looking straight, like there's not like a straight line. You're actually, it's almost like you see the sun as though it's way out here, because the light, by the time it hits you, it's kind of like looking through water, I guess. So I guess my challenge to you would be, can you come up with, and I guess if you don't want to actually ride your bike or do something, but maybe you can challenge someone else. I don't know if I could actually do it myself with where I'm at, but come up with the challenge that would have someone prove that even given this model, that it doesn't add up, that the Earth actually is a sphere. So maybe someone who measures like a distance or something like that. I'm not really sure, because I haven't studied this model too much. But anyway, thanks for watching this, and I hope to see more videos from you.